Hello dear users of digital photogrammetric workstation PHOTOMOD. We are continuing a series of video tutorials dedicated to working with PHOTOMOD 6. The theme of today's video is 3D points calculation. Let's start PHOTOMOD and open previously created project Allen. To calculate 3D points is possible just in adjusted PHOTOMOD project. Information about a project state is available with clicking Project State Summary button. As you see, all kinds of orientation are done and the project is adjusted. Before specifying and starting automatic 3D points calculation, it's necessary to create a grid in a frame of which these points will be calculated. I click Grid, Create. In Layer Manager, a corresponding layer has appeared. Keeping Shift key of keyboard, I draw a grid area with a mouse. Then I specify grid properties, select X and Y step, say 2.5 meters for X and 2.5 meters for Y. Directly with such density, 3D points will be calculated. Size of grid step depends on some parameters, type of terrain and requirements to output them accuracy. Generally speaking, for creation of 2000 topo map of mountainous region, a size of grid step should be less than for creation of 10,000 topo map of a plain region. Rotation and Z level remain in default. A mean GSD of images in the project is noted here as well. In my case, almost 7 centimeters. Press OK. With creating overlapping map, it's possible to note that in the project there are areas that are covered by several stereo pairs at once. While starting automatic 3D points calculation, these areas firstly will be covered by 3D points calculated from the one stereo pair, say 116, 115, and then from the other one stereo pair, say 46, 116. Heights of the same point calculated from different stereo pairs will be varied a little bit, of course in a frame of acceptable residuals after an adjustment. In order to prevent such situation and to decrease a total time of 3D points calculation, it's necessary to build pre-regions preliminary. Block, build pre-regions by Voronoi diagram with using of stereo pairs frames and removing of slivers in position min. OK. Then we should specify settings of automatic 3D points calculation. Vectors, compute points automatically. Firstly, I select correlator preset. In drop-down menu, a list of several resets has appeared. Desert, mountainous terrain, rural area 2, urban area, and so on. Despite all presets initially are specified individually for each type of terrain, numerous tests proved that the best time quality configuration of the correlator is rural area configuration. We recommend to use it for initial 3D points calculation. If results will be bad, it's possible to activate other presets, and it's possible to edit already created preset. You can read in detail about settings of correlator in PHOTOMOD user guidance. All images option is selected for search area. If necessary, it's possible to select just several images. For example, if in a project there are a lot of images with a large overlapping area between each other. I activate Use Pre-regions option and select Pre-regions vector layer. Since of more calculations, using of interstrip stereo pairs slows down 3D points computation. As a rule, using of in-strip stereo pairs is enough. In order to filter points with big z-height errors in images that have small or null intersection angle, it's possible to use corresponding option. Minimal angle is specified by a slider. All points in stereo pairs, intersection angle of which will be less than specifying angle, will be filtered. On the base of early specified grid step, a grid area and approximate number of grid nodes are calculated. In order to start 3D points computation, a correlator should know in which elevation range it's necessary to search them. We will use stereo pair elevation range option as an initial approximation. While activating stereo pair elevation range option, an elevation range is calculated separately for each stereo pair of the project on the base of heights of previously measured points. While activating project elevation range option, an elevation range is taken from values of minimal and maximal heights that we specified in the project properties. Range expansion option speaks for itself. If in the project properties 450 meter and 550 meters were specified as minimal and maximal heights, an expansion of this range on 10 meters enables to change it to 445 and 555 meters correspondingly. If necessary, it's possible to use fixed values of heights along with maximal shift from them as initial approximation. For example, if to specify 400 meters fixed elevation and 50 meters maximal shift, it will be identical to elevation range 350-450 meters. If there is dam on the territory involved, it's possible to use it as initial approximation as well. The more accurate and adequate an initial approximation is, the faster 3D points will be calculated. Additional options should be considered as well. Safe quality assessment to attribute option enables to keep a value of correlation coefficient and other parameters in attribute of which measured point in order to provide a user by quantitative criteria for assessment of measurement quality. If correlation coefficient will be low, there is a probability that such point is measured wrong and should be filtered. Delete redundant points option enables to thin out points measured too close to each other. Value of minimal radius is specified in menu Service, Settings, Correlator. Random points distribution option enables to disperse 3D point measurement from the grid node in a frame of a half of grid step. Accuracy control with reverse stirrup pair option enables to increase reliability of points measurement due to use of reverse stirrup pair. We recommend to use a set of additional points in default. After completing of 3D points calculation, results can be loaded into vector layer of the project at once or can be saved in the PHOTOMOD resources. If necessary, split it on parts. It's rationally when vector layer is too big. To accelerate a computation process, we will use a distributed processing mode. Preliminary, we start a distributed processing control center. A monitor symbol with a green display will appear in a system tray. Click Distributed Processing. Select Working folder in which calculation results will be stored and select a mode of splitting calculation area into tasks. For more effective using of computer, it's recommended to specify sizes of rectangular sheets in a way that a task's number will be proportionally to number of PC cores working in distributed processing mode. We have 8 cores and 8 tasks of distributed processing. I press OK and check that in distributed processing center after run mode is activated. Well, all tasks are completed and I load created 3D points into the one new layer. A visibility of other layers can be deactivated. To change a color, a shape or a size of 3D points, I click on the rectangle next to layer name and change a color of objects with classifier to red, for example, a size of point objects to 1, a shape remains without changes. On the base of loaded 3D points, I build tin. Tin, create. I keep just 3D points as source data, quasi-contour displaying with 5 meter step is activated. Quasi-contours enable to perceive a relief and its amplitudes better. Border of tin is convex. Okay, if necessary, an arbitrary polygon can be used as a border as well. Okay. Well, tin created on the basis of automatically calculated 3D points looks like this. Tin and 3D vectors can be saved to PHOTOMOD resources. In the next video tutorial we will learn how to edit them in a stereo mode, filter them and create DTMs and DSMs on the base of tin.